what we're going to first do is we're going to think about how we solve the problem. Now in the Fibonacci sequence, you guys know, okay, there's about the top left. It goes 0, 1. That's what we start off with, correct? Okay, and then from there we would take the first value and we would add it to the second, so that would become 1. Now that first step, how did we do it? First we had to remember, so if we have a brain, I can't draw a brain, but this is a brain. Does that look brainish? Okay, that's a brain. It's a human brain, okay? Anyway, we've got to find a space in our brain to keep track of the fact that we're dealing with 0. Does that make sense? And we need to go, okay, cool, we think about it, we've gone 1. We do this automatically, but we do remember the first value, the second value. We then do addition to come up with a third value. Does that make sense? So we come up with a third value to get the answer. Now, from this process, we now, which two values are we looking at to come up with the next number? So 1 and 1. So we now look at this number and this number, and then we go to 2. So we create the value 2. Now this next number also gets put, but what would be the easiest way as far as memory usage in our brain? To replace the first one. So in other words, the 1 would get put forward to that position, to that position, to that position. So it would go forward, 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 and that's how we solve this problem. Then 1 plus 2, we look at the next two values, which get put into the working area of what we want to add. Okay, that drawing is looking very ugly. It doesn't make any sense. But we look at the first two values. So basically in our brain, which is now a bigger version of our brain, we have the two starting values. So the start value, val 1, start 1, and start 2. And those are the two values we're constantly looking at, and then the third value is our answer sort of value. And we're just continuously just swapping them one back. Does that make sense? Do you guys understand that concept? Now, how we draw that into a flowchart, that's the test page, fancy that. How we draw that into a flowchart is we would literally start, okay? So we start. Now, what variables do we need? If we look back at our brain, what are the variables that we have in our brain? What are the stuff that we need to remember? Okay, X, Y, Z. In this case, we call it start 1, start 2, and answer. Okay, you guys can call it X, Y, and Z or anything, but we need to declare variables. Now, what data types would they be? Where to stop? Yeah, as far as that is concerned, as far as us, we would just generally carry on until we would need a stop position. And yes, we would also need to remember where we actually stopped, so we'll need a stop space in our brain. Okay, but now our memory location we have to create in RAM, so we declare our variables, which will also create it in RAM. And what data types will these variables be? All of them are numbers, so they are ints. Integers mean what? Whole numbers, right? So it is an int. So we declare variables int. Okay, you guys happy with X, Y, Z, or would you rather do start 1, start 2, answer? Okay, X. I'm going to do it shorthand, Y, Z, and max. Okay, so those are the variables that we need. The next thing we need to do is we need to initialize these values. How would we initialize these values? So X would equal to 0, Y would equal to 1, Z would equal to X plus Y. That's the starting positions. But quite frankly, this X plus Y we can look at separately logically because Z is the answer. Now, from there we would need to get from the user what the max is, correct? Okay. Now, originally, now, it's all fair and well us working it out, but we want what are we doing here? We want to output it. We want to actually show the user the answer. So when we're doing the Fibonacci, we want to display it somewhere. We don't want to just keep it in our heads. We need to visually interact with the user and show this is the Fibonacci sequence. Are you laughing at me? That's rude. Okay, fair enough. I don't blame you. Anyway, now the next thing that is on there is we would want to output it. Now, generally speaking, you guys have previously just been outputting as you've got the answers, correct? But now I'm thinking, why don't we store it in a text variable, and then once we get it into that text variable, we just display the whole conclusion at the end, rather than, because remember with show message dialogs, you don't want to have to click OK for later stage. So what we do is we create a text variable. What's the Java equivalent of a text variable? String, and we'll call it output. Okay. So I want to begin with, I want to start off with, I want to output is equal to, it is a process, because I'm storing something. It's not physically, I'm not actually outputting it here. What I'm doing is it's a square because it's a process. I am putting this into the text variable. So the output is going to be equal to x plus a comma. Why did I put in inverted commas? To show that it is text plus y. So all that's done so far is it's shown the starting positions. Okay, so 0, 1. You guys got this so far? Okay. Now we want to work out z, also calculation. So it's a process, so it's in square. Z is going to equal to x plus y. How do we determine if we want this value or not? We need to figure out whether it's for max. What have I forgotten to do? I have forgotten to input max. Okay. Whoa, that's not cool. F8 is pause. Oh, it went on to... Damn it. It went on to screensaver. That sucks. Okay, pause. Okay, so the screensaver has now been turned off. Let's continue. Okay, so what we've got here so far is we also needed to input max. I should have actually done this previously, but it doesn't matter. We'll now get the user to input what they want to stop at. So we would go input max. Okay, so we'll get the users to state what you want max. Now, we want to continue. Yes, a very badly drawn parallelogram. It's parallelogram. Anyway, now from there, how would we do a loop structure? Because we want to continue doing this until we get that. A diamond, 100%. Okay, so diamond, we go like that. Is our diamond, and we want to carry on while z is not equal to, because it will never be equal to max, while it is less than max. Okay, I would maybe even say less than or equal to max, because if the max value was a part of the Fibonacci sequence, you would want to include it. Okay, so now we have the value if yes. Okay, so if the answer was yes, what do we want to do? First thing we would want to do is we would want to display z, because z is less than or equal to max, so we do want to display it. So we want to add it on to our output. Now how do we add on to our output? We make output equal to output plus a comma to make it visually nice, plus a z. So we'll add z onto it because z is smaller than the max value. Now we need the next process to work with the new values. If we go back to our brain, what was the next process? Is we had to move everything down one. So we now started looking at the next two symbols. How did we do that? We made x equal to y. So we made this move that way. We made this move that way. So everything just moved one forward. And z, so everything moved one forward. So we would literally make x equal to y, y equal to z, and then z equal to y, x plus y, x plus y. Okay? And then we would go back to the beginning of this condition, because this is literally a condition, and we would then check. It's a condition. We would simply check if z is still lower than max. So we would continue doing this loop until we got to the value, the max value we wanted. Now what would we want to happen if it was no? We would want to output the final. Is this a better parallelogram, Matthew?
Yes, sir.
It's very pretty. Oh, yeah, anyway, it's yeah, output. And what we will output is we'll output output. Okay, so we're outputting the variable output. I should have probably called this S output just to make it more identifiable. So we'll make S output, S output. So we'll output S output. Okay. So we'd output S output, and then we would end the program. Do you guys follow this so far? Yes. Now, how do we convert that? This is how the Fibonacci sequence works. How do we convert that into code? First of all, the start. The start is the static void main. This method is where the program starts. When you press play, this is where it's going to start. Does that make sense? Okay. Now the first thing we want to do is we want to declare our variables. So to declare a variable, it always structures. Remember, this is just a comment, just so I can know what you do. It goes data type. What after data type? Name. Okay. So now in this case, we want an integer. Now you guys can do this. I haven't shown you this before, but literally x, comma y, comma z, comma max. I can declare multiple of them in one line. But realize I have not initialized them. None of them. Ross, Bentley, just so that the video is sure who it is. Focus. Okay. Now what we've got there is we've now got x, y, z, and max. Now we need another one. We can't declare. Yes, we can declare multiple of the same data type in one line, but what about for a string? We want the string s output. So we would go s output, which, sorry, we first need to say data type, and we're going to call it s output. Okay, so we've declared it. But now, remember, we always have to initialize our values. What do we want to initialize x as? 0. What do we want to initialize y as? What do we want to initialize z as? X plus y. Okay. What do you mean? So basically what we're doing is we are saying, but realize this is initializing. You're saying this value, remember what I say, that it reads from left to right, so it reads it this way, then it executes that way. So x gets the value 0 stored in certain. Remember, this whole process here, we are creating in the declare variables, we are creating pointers saying that this space in RAM is going to contain this stuff. When we do this, we are actually physically putting a value into RAM, and we're physically saying this pointer must point to this space in RAM. Does that make sense? So we're literally saying this pointer here must point to that, and this is what type of data it is, because you told the pointer what type of data it is already. Now, on from there, we now need to initialize our string. What are we going to initialize our s output? And guys, remember, what am I doing here? Well, how did I make that finish? Control spacebar to keep the casing correct, because if the casing is wrong, it will not work. Now, what do we want our output to be here? X plus a comma. Okay, so it will start off with the intro, because we always started, like in the Fibonacci sequence, we would always have to have the starting two values. So we'd have to already set that to be our output. Okay, now we need the user's input to get the max. So user's input. Now, max is an integer. We utilize to get, can I do the following? Max is equal to JOptionpane. Oh, that's not an equals to sign. JOptionpane. To get user input, we utilize JOptionpane, which is a class, and we utilize the method show input dialog to get input from the user. Now, if we take a look at the, unfortunately I can't see it directly here, but if you take a look at it, it returns a string. So we can't work with that because it returns a string, not an integer. So we have to do another method. So what I'm going to do is I'm going to do it in 2 steps. We can do this in 1 step, realize it, but just for simplicity's sake, I'm going to do it on 2 steps. So smax is equal to JOptionpane.show input dialog, which is a method. Now remember, what are these called here? It says that I have to send an object message through. What is that called? A parameter. Blah, 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 blah. Okay, so 100% it is a parameter, so we can send it through to it. Now, object message parameter, we are going to send through the value enter max. Guys, please make it as user-friendly as possible. You don't want to like make it just enter number, what number. I don't know, maybe enter max is not. Anyway, so now we want a max. We now need to convert this string into a, and again, we are using somebody else's classes. The whole thing about object-oriented programming is that we utilize other people's objects. And what object do we utilize to convert it? Parsing, but integer. So we utilize the integer class, because remember, anything with a capital letter is a class. So someone created a JOptionpane class, which allows us to get inputs from users simply. Somebody created an integer class, which allows us to modify integers, and we go dot, and then you'll see parseInt is there, and then we want to use smax. So it will now convert that string into an integer to allow us to store it in. Remember, again, reads to the right, executes to the left. So it will then get passed back. So, and again, the parameter, when you guys press Control Spacebar, you'll see the data type it returns an integer. What is the parameter? In other words, what we have to send through to it in the post box, we have to send through to it a string, in which case smax. Now, The next thing is we got to do is we got to create a loop, because we want to continue looping until it's beyond the maximum value. Now, in this case, it's a triangle. Now, the conversion of a triangle over here, this triangle, is an if statement. Diamond triangle. It's a diamond. Anyway, it's two triangles. Anyway, this condition, if it's just a condition, in other words, there are two paths to go down and then it would end, then it would be an if statement. But in this case, it loops back to itself, so then we actually utilize a while. Okay, so it's an if it just goes across and then down. It's a while if it loops back to itself. So now, in this case, we want to do while z is less than or equal to what value? Max. Okay. Now again, remember, use your control spacebar. Now, an important thing, open curly brackets, enter. You'll immediately notice my cursor. What does my cursor do? It indents. Okay. Now, with it indenting, okay, it is still recording. Just double checking. I didn't remember if I had paused. If you do not indent, you do not know. Remember with when you HTML coded, how difficult was it if you just coded everything in the same line? It was challenging. You need to indent to show where you're inside. As you guys notice, here a class, we're inside the class, so it automatically indents one. This is a method, we're inside the method, so it automatically indents one. So now we're inside a class, which a method inside a class. Does that make sense? And now we're inside a while loop, which is inside a method, which is inside a class. And trust me when I say it gets complex, it gets extremely complex. If you do not tab Java, you cannot you cannot figure out where you are. Okay. Now what we want to do is we want to make s output to be include the value z. Now remember, we have to go s output plus a comma plus, okay, a spacebar just to be more grammatically correct, plus a z, the z. Do you guys follow that? Now here's the thing. This s output is equal to s output plus. Remember, we are adding it onto the end. We are appending what's called concatenate, actually. Sorry, it's over there. I can't actually put my finger at that. Anyway, I was trying to. This s output, okay, is very, very common to append or to increment or add onto. They've made a shortcut in Java. Instead of this s output is equal to s output, we can literally do the following: plus equals. So now what that is doing is it's saying s output is equal to s output plus. So plus equal just means you are going to add it onto itself. Does this make sense? No, it doesn't work. It's what's actually what could be determined. Rowan in grade 12, he always calls it Java has too many hacks. Because basically this is a hack. It's like it tries to go against. So when you go plus equals, it kind of goes, okay, bypass, we're doing this. And there's a lot of nice, funny little hacks that you learn. Like, for example, the fact that we can declare multiple variables in one line is you could also kind of determine as being a bit of a bypass of proper coding. Because when you execute it and it compiles it, it would actually declare them separately anyway. Okay, now from there we've got the output. We now need to do the little different process. So we're now doing the process lines over here. We need to make x equal to y equal to z, etc., etc., etc. So we'll make x equal to y equal to z, and then we'll make z equal to x plus y. Okay, now this would be it, wouldn't it? But now we need to output to user. The while inside, whatever's inside between these two brackets. Now it's very important you keep track of where you open and close your brackets. So where you open and close your brackets, you'll notice that the output, whatever's in the middle of that, so this over here that I've highlighted now is going to be looped until that condition is false. I've now gone outside the loop, so that means once that loop is finished, in other words, once this condition, because remember this returns a boolean, doesn't it? This area here returns a boolean. So if that returns a true, it will continue inside it. When it returns a false, it will exit that and will now continue with what's below it. And what we want to do below it is we want to output the, so we would go, how do we output? So again, we utilize a class. And which class do we utilize? JOptionpane, and we use the method inside that class show message dialog. Again, we look at the parameters. I'm just going to drag this down so we can see all the parameters. When you look at the parameters, it is a void, which means it doesn't return anything. It says that it needs a parent component. Do we have a parent component? but we need an object message. We're orphans right now, so we are going to go show message dialog. The parent component we're going to keep as null because we do not have a parent, because we have not coded a parent frame or anything. We are then going to display out. What do we actually want to display? S output. Okay, and now this here is the code for the Fibonacci sequence. Just to run it to show you, and then we'll get to the question phase, which I'll record in a separate video. When you click play, it will eventually run. Old laptop. Windows 8 is actually more optimal than Windows 7. It's just the fact that the PC is old. Anyway, enter max. Let's say if we go up to the number 50. Okay, 50. Cool. 50, okay, then you'll see the number will go 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. The next number beyond that would be 55, so obviously 55 is not included in this, so it wouldn't display it. Do you guys get that? Okay, so that is a Fibonacci sequence, and I'm going to stop the recording now before I do questions afterwards.